My name is Amim Knabben. I work in the VMware and the standalone Tanzu Kubernetes grid. I'm the tech lead for the compliance node and for Windows offering as well. So today I'm gonna speak about the gRPC security and service mesh, in particular in Istio service. I have like 20 minutes and I figured out this is not much time to cover the entire presentation, so I have a few demos that I will skip, but you can download the presentation in the scat.com and see the demo live later. So for the agenda today, I will start talking about the mesh and zero trust security and how zero trust is something that was adopted by the entire cloud native ecosystem as a standard. Then I will talk about SPIF and service identity. We'll look at the SPIF specification and SPAR implementation inside the Istio. We're going to the Istio, East-West traffic specifically for gRPC. We'll take a look in the evolution double quotes or the latest things that are happening inside the Istio. So we'll go in the gRPC proxy list. We saw like the keynotes before. There are some things going on in the proxy list side as well. And we're going to go in the ambient mesh. That's where I'm more involved in researching more. And we hope we can conclude this in the time. So introduction here, the mesh in zero trust. So why does it matter? Right? So Istio provides like security features that are like, well, battle tested. It mitigates like the external and external, internal and external threats that you have in your own platform, in your architecture or enterprise. Service mesh can give you ownership and authentication and authorization layer, and they are decoupled from the development experience, and you are using this kind of architecture. Istio provides audit protecting, so it gives you like protection against no repudiation. You can have like logs and you can have metrics that proves your service was accessed. With all these capabilities, you have like a strong gRPC functionality or architecture that complied with the zero trust security specification. So what is, in the end of the day, the zero trust security thing that everyone is talking about? There's some Gardner conversation before all this stuff that started this movement, but the main pinpoint is this NIST paper SP 800-207. And the zero trust model assumes that an attacker is present in your enterprise-owned environment, and you are responsible to secure all the pieces, all the assets inside your architecture because you don't trust anyone, like in real life. So it enforces the principle of least privilege for network and applications, and it's not a single architecture, but as guiding principles for workflows, system design, and operations. Zero trust and service mesh and CNIs and all these products and vendors are not silver bullets. It just defines like best practices and good guides on how you can implement this kind of architecture. So it's not a product that will define how you protect your system. It's like a lot of factors that together and with the best practice give you the correct protections. If you get the spec and you get this paper, you have some interesting principles of zero trust. I highlighted some ones that match with this presentation. The first one is 4. I think 4 is access to resources is determined by the dynamic policies and may include other behavioral and environmental attributes. So the policies, according to the specification, are set by subject or the entity that's performing the action, an action, the action that's being performed by the subject, and a target, the object that the action is being performed upon, and a condition. So this is like basic traits that you need in your policy to define, and is defined by these principles, by this spec. Other point that the 50th point here is the enterprise monitors and measure the integrity and security posture of our own and associated assets. One important and interesting part is the auxiliary components. So you have not only your zero trust model and architecture, you have auxiliary components that creates and enhance the protection. And they include like enterprise, public infrastructures, CMs, threat and intelligence feeds, networking, and system log, activity logs, all these other components that came up and make your architecture more secure. So if you read the documentation like the spec, you can see they define two main pieces of in this diagram. And this is not a coincidence that these two implements this, because it's like a default telecom control plane, data plane model that Kubernetes implements as well. So they define this as a policy decision point, or PDP, where your control plane, or EC2D in this case, allows you to insert via the CRDs or manage the entire data plane. Is like the brain of your architecture. So EC2D makes this role of policy engine and policy administration. The other side of this is the data plane, where your proxy has like an envoy in the traditional architecture, and you can consider this as a PEP, and this is responsible for enabling monitoring and management the connection between the enterprise resource and the subject that your policy will be applied in the, as you're going to see in the front, with the connecting like and being managed by this EC2D. EC2D and Envoy communicate by the XDS protocols, a bunch of protocols that they communicate to translate like these policies and other things like secrets and routes and how you configure dynamically your Envoy in your data plan. Cool. There is one part that's important here. That's the core of what everyone is using nowadays. I think Google Cloud is implementing a lot of things in the SPIF and Spire side as well. So SPIF is like a service identity. This is like the core of how you start to identify your services. So you have your gRPC workload, and SPIF is a way for you to identify how your workload is identified by other peers. SPIF uses the SPIF ID. That's the format of SPIF ID. You have a trust domain, you have a workload identifier, and you have like two ways to change this information across your cluster. You have like X509 certificates, and you have JOT tokens. So you can use like both east-west traffic or north-south traffic using these two ways of identifying the SVID. Good news is that the Envoy needs to use SPIF for mutual TLS authentication, and this is transparent when you start to using this thing. So when you are install Istio in your cluster, you have like an authentication, an encryption and authentication by default for the peers that are connected on the services that you have inside your cluster. Okay, so SPIF is the specification. You can get like, there is a good book around on the SPIF website, and the Spire is the implementation of that. So someone implemented this Spire outside the entire Istio thing, but Istio implements their own Spire based on the SPIF implementation. So SPIF, the SPIF authentication, the attestation works for both node and the workloads. Those are the two things that you need to attestate or authenticate. These pieces are pluggable. The servers and agents are pluggable. The first thing that goes is the node attestation. It's required for the agent to authenticate and verify itself when connected to the server. And the second is the workload itself that you need to pass and authenticate in the Spire server API. This is a more complex example. So we have like, you have like two front ends in the corners, and in the middle you have the back end, and you have this Envoy proxy in the middle of them, doing this filtering and applying and having these policies where you can identify what each workload is and which one is authorized to access. In this example here, we have an open regular implementation here of filtering of like, okay, you have a valid path, is this a request method, and you have like SPIF ID for this particular service that you are allowed to access. This is like the initial implementation in the website. You can see the example. You can download these and run your kind cluster and understand how these pieces works. So after that, the evolution, I don't know if this evolution, the history is the evolution, but you can have another implementation of Istio Service Mesh. And there are some options for us here in the Service Mesh to be compliant with this zero trust architecture. So the first thing is the continuation of the gRPC proxyless. So the gRPC proxyless, as the other keynote was talking, you have like this library inside your own Go code. So you have like a data plane inside your own application. You don't need the proxy, you don't need the envoy anymore. And this is pretty cool. There are some advantages, but you still need to bootstrap a file, and you still need the issue agent to get this information on how to connect your control plane, how you're going to connect your control plane and do the XDS conversation. The trait here is that all logic resides in the application for the control plane connection. The other thing that's going on with the serverless, with the sidecar-less ambient mode here is like you can handle all the traffic east-west without envoy in the middle of that. So if you see this diagram here, you can have like east to CNI that bring up these iptables rules, and all the traffic that's inside the node is passed by the Z-tunnel. So Z-tunnel is a Rust demo set that runs on each node, and this gives you layer 4 capabilities. It doesn't give you layer 7 capabilities, but at this point you have H-bone traffic encryption from one side to another. You have MTLS, you have SPIFFE ID, you have like basic authorization without any sidecar or any envoy in the game. If you want to improve like your layer 7 capabilities and like filtering on gRPC policies, you can add a waypoint. An endpoint is still an envoy, but it's not like a sidecar injected in the webhook admission. When you start your workload, you can or cannot use the layer 7 proxy, so you can decouple, and then if you want, you can run a deployment, and you can scale this by namespace or service account instead of like having one-on-one option. All right, so how the authentication and authorization on these two works? CRDs. So install your CRDs, you manage your CRDs, and you have like for authentication, I have this pure authentication CRD, where you can set the mode, like everyone that's being the mesh needs to be strict and needs to use that. And in the authorization side, you can filter out by the policies that we saw in the beginning. So you have like the target in the selector of the match label, you have an action is allow or denied, you have the subject that's generating this, you have the principal that's generating this, and you have a condition where you can filter if this rule is applied or not. So in this example here, we have a service and you have a method, and everything that's coming from gRPCA is allowed to pass through this selector. The selector is for the waypoint proxy. I don't think we have the time for the demo, right? Let's go to the good part. So I set up here. I set up here an issue cluster, a kind cluster locally. Bring up some workloads on that. That's an example of the workloads. So what I did is like I go into one of the workloads and start to gRPC crawl for the other server. So you have here like a service called gRPC, and you have this dummy server string. And then I will apply this policy. So I have gRPC and gRPC, and they are connecting each other via gRPC. And then I apply an authorization policy in one of the waypoints. So this label is directly for the waypoints, not passing to the workload. And I have this principle saying, okay, everything that's coming from gRPCA going through the dumb server stream, service and method, and I need to enable the reflection because I'm using the reflection behind the scenes as well for this app. I apply this policy and I say everything that's coming from gRPCA, it's fine, it's good to go. So I go to gRPCB and do a request for the gRPCA. And this okay, are back, access denied. You cannot go from gRPC A to gRPCB, gRPCB to gRPCA. So go over and SH into the gRPCA and go to the gRPCB, and you can access that. So you're filtering by your method and you are gRPC curling the other side with the correct information. So let's say I change it, my method here in the service and say real server is the allowed part. Go back in my gRPCA that is allowed to do the request by the subject and try to do a request again for the gRPCB, and now I have an access denied because I'm at this point filtering the layer 7 gRPC methods. Roll back again. Yeah, so if I roll back again, you can access this back. All right, so concluding the presentation here. I did some tests in the consumption. That is like some issue testing, load testing, validation, where you can like do requests and have some interesting results, like super fast. Even if we are talking about like 1.9 milliseconds for like 1,000 requests per second on a simple gRPC call. That's fast in most of the cases. This is the traditional sidecar. We have like an envoy running here. For the layer 4 Z tunnel, we are talking about 300 microseconds. What's ridiculous. And for the gRPC proxyless server, we are talking about 200 microseconds. Picking the right choice for you. We have like those two modern ways to do things in the gRPC side and are mostly integrated with Istio. Proxyless in the Istio side is still experimental. So if you're interested that, I think the traffic directory is a better choice because it's GA already. But as you saw, it's much faster. The consumption footprint is lower. Is decoupled from the control plane, but coupled in the code. Decoupled from the data plane, but coupled in the code. And the ambient mesh is another solution that's getting some traction nowadays. It's pretty interesting. You have more integration with Istio. Can be a good choice if you're looking for like metrics and more traffic controls and other features. That is, shout out to Vladimir that helped me creating the content. And that's it. Thanks.
Question about the enforcement.
Hello, this is Sumant. Have you done the testing with traffic director, similar results? Like, is there a difference with Istio?
I think it's a good place for you to look around and have a good answer about that.
Thank you. Yeah. And the demo you showed, is that open source or something we can try?
It's on my YouTube channel. I maintain a repository with these make files. Make is like a make file thing for Go, and then you can run all these steps by yourself on kind. You just need kind.
You put in kind and K9. Okay. And one other question. So identity here, right? Authorization, I saw that one. So how did the server identity? Is it using SPIFFE-based identity for the service identity?
Yeah, it's by default. Istio gives you this by default.
Okay,
Every time you get a workload, it gives you this identity for your workload, both in the ambient mesh without sidecars and the sidecar part.
Wonderful. Thank you.
So for the authorization part of it, I saw the configuration file for the STO, right? Will this be translated into an authz understandable policy, or how does that work?
This is a CRD that's translated automatic for this airbag. So this, without this part here, this part here, that's layer 7. This Z-tunnel still can parse from like only the subject. You cannot do like layer 7 on Z-tunnel. You can do everything on waypoint and envoy, and you can do everything on gRPC proxyless as well. This will be translated to gRPC proxyless in issue experimentally.
And the enforcement happens at the gRPC server itself.
No, it happens in the layer before that. So you have in the ambient mesh, you have like this waypoint part here, that's the envoy. It happens here, or Z-tunnel, it happens here. This is a Rust process that's running in the node. Or in the proxyless, it happens in the application.
Thanks.
Hi. I would like to know how is the service account passwords being managed, if there is any, on
Password?
if there is any on the waypoint proxy.
There is no password for this service account.
Okay.
So this is something that's cool, because if you have permission, you can impersonate this service account, right?
Okay.
In the namespace. So the isolation is by namespace, and this is super dangerous because like after you have these policies, everything integrated, and then you own this namespace, you can create and replace an existing service account for a pod if you have permission to create this pod.
Understood. Thanks.